Welcome to Amader Pathshala. Today I will take subject mathematics, class 11 12, chapter 4 polynomial and polynomial equations. Polynomial. A polynomial is an algebraic expression whose terms are made up of the product of one or more variables with non-negative integral indices and constants. A polynomial may contain one or more terms. The general form of polynomial in one variable is a to the power 0, a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus plus an. Here a0, a1, a2 an are constant terms. In a polynomial, the power n of the variable x is always non-negative integer. The power always is non-negative integer. The expression x plus x to the power half plus 5 is not a polynomial because in the second term is the power x is half. After completing this chapter, students will be able to solve quadratic equation by resolving into factors. Find the general solution of the quadratic equation. Find the relation between roots and coefficient of a quadratic equation. Explain what is a discriminant. Determine the nature of roots of a quadratic equation. Form a quadratic equation with given roots. Determine the values of symmetric expression of roots of quadratic and cubic equations. Number 8. Explain what is a polynomial and determine its degree. Number 9. Find the relation between roots and coefficient of a cubic equation. Formation of a quadratic equation. If alpha and beta are the roots of the quadratic equation, x square plus bx plus c equals 0, then alpha plus beta equal minus b by a and alpha beta equal c by a. This is the sum of the roots of the equation and product of the equation. General solution of quadratic equation. The standard form of quadratic equation x square plus bx plus c equals 0 and multiplying both sides by a square x square plus abx plus ac equals 0 or a square x square, that means x whole square plus 2 ax b by 2, 2 multiplied 2 divided plus b by 2 whole square minus b by 2 whole square plus ac equals 0. A square plus 2ab plus b square, that means a plus b whole square. Here ax a and b by 2 b, or ax plus b by 2 whole square equal b square by 4 minus ac, or ax plus b by 2 whole square 4 LCM b square minus 4ac by 4, or ax plus b by 2 equal squaring root plus minus root over b square minus 4ac by 2a, or ax equal minus b by 2 plus minus, or x equal minus b plus minus root over b square minus 4ac by 2, or x equal minus b plus minus root over b square minus 4ac by 2a. There is a two roots, x1 minus b plus root over b square minus 4ac by 2a and x2 minus b minus root over b square minus 4ac by 2a. In equation 1 above, b square minus 4ac, that means b square minus 4ac is called the discriminant of the quadratic equation. I that discriminant d equal b square minus 4ac because it determines the state and nature of the roots of the equation. Nature of the roots of a quadratic equation depending on the condition of the discriminant. Let ABC are rational number, then if b square minus 4ac, that's mean discriminant, b square minus 4ac greater than 0, then the root, it is a perfect square number, then the two roots of the equation are real and unequal and rational. If b square minus 4ac greater than 0, but is not a perfect square, then the two roots of the equation are real, unequal and irrational. Number 3, if b square minus 4ac equal 0, hence the roots of the equation are real and equal. In this case, x equal minus b by 2a, if b square minus 4ac less than 0, then the roots of the equation are not real. In this case, the two roots are always conjugate, complex or imaginary to each other. Now problem, if the roots of the equation x square minus px plus q are consecutive integer, then prove that p square minus 4q minus 1 0. Here the quadratic equation x square minus px plus q and root are consecutive integer. That means consecutive integer 1, 2, 3, 4, 5. That means the difference between roots is 1. If first root is alpha, then second root alpha plus 1. We know that the sum of the roots alpha plus 1 minus b by a, that means x square bx plus c equals 0 minus b by a minus b minus p minus p by 1 minus plus equal p. Alpha plus alpha, 2 alpha plus 1 equal p, or alpha equal p minus 1 by 2. And this is the sum of the roots. The value of alpha equal p minus 1 by 2. And the product of the roots, that means alpha into alpha plus 1, c by a, q by 1 into x square. The coefficient x square is 1. The q by 1 equal q. Or value, putting the value of alpha p minus 1 by 2, then put the value of alpha p minus 1 by 2, alpha plus 1 p minus 1 by 2 plus 1 equal q, LCM 2 p minus 1 by 2, LCM 2 p plus 1, p minus 1 into p plus 1 equal p square minus 1 2 into 2 4, or p square minus 1 by 4 equal cube. Or p square minus 1 equal 4 cube, or p square minus 1 minus 4 cube equals 0. Therefore, p square minus 1 minus 4 cube equals 0, hence proved. Number 2, if one roots of the equation ax square plus bx plus c is n times of the another root, then show that equation nb square equal ac into 1 plus n whole square. Here the pattern of the roots, one root is n times of another. That's mean if the root, one root is n, then another root n alpha. Therefore, the two root alpha and n alpha. Then sum of the root alpha plus n alpha equal minus b by a, and product of the root minus b by a, that's mean alpha plus n alpha here, common alpha. The alpha into 1 plus n equal minus b by a, or alpha equal minus b divided alpha into 1 plus n, again a into 1 plus n, that means a into 1 plus n, again alpha into n alpha equals c by a, or n alpha square equals c by a, n putting the value of alpha minus b divided a into 1 plus n whole square c by a, minus cancel, then n into b square by a square into 1 plus n whole square equals c by a, and cross multiply n into b square nb square equal ac into 1 plus n whole square, or nb square equal ac into 1 plus n whole square. If the roots of the equation x square plus bx plus c are alpha beta, from the quadratic equation whose roots are alpha plus 1 by beta and beta plus 1 by alpha. Here roots of the quadratic equation x square plus bx plus c equals 0, roots are alpha beta. Then sum of the roots alpha plus beta equal minus b by a and alpha beta equals c by a. So, sum of the roots alpha plus, finding the equation of the roots alpha plus 1 by beta and alpha plus 1 by beta and beta plus 1 by alpha. So, sum of the new equation of the roots alpha plus 1 by beta plus 1 by alpha, then alpha plus beta, that's mean alpha plus 1 by beta plus second root beta plus 1 by alpha equal alpha plus beta plus 1 by alpha plus 1 by beta. 1 by alpha plus 1 by beta equal alpha plus beta plus alpha beta LCM, that's mean beta plus alpha, that's mean alpha plus beta, and putting the value of alpha plus equal alpha plus beta and alpha plus beta and alpha beta, then we get minus BC minus AB by AC. Alpha plus beta, putting the value of alpha plus beta minus B by A plus alpha plus beta minus B by A and alpha beta C by A, alpha beta C by A, alpha beta. Then after calculating this result minus BC minus AB by AC and product of the root alpha plus 1 by beta multiply beta plus 1 by alpha, then alpha into beta, alpha beta, alpha plus beta plus 2 plus 1 by alpha beta, putting the value of alpha plus beta and alpha beta, then calculation C plus A whole square by AC. We get the sum of the roots this and product of the root this, then new format equation. The required equation x square minus sum of the roots into x plus product of the root equal, or x square minus sum of the roots we get minus BC minus AB by AC into x plus product of the root we get C plus A whole square by AC, and then calculation AC LCM, that's mean AC x square plus minus common plus bx into C plus A whole square equals 0. This is the required condition of this required equation. Number 3, find the equation whose roots are sum and product of the roots of the 7x square minus 3x plus 14. Find the equation whose roots are the sum and the product of the root. So, this equation, let the equation 7x square minus 3x plus 14 are alpha beta, So, two roots are alpha comma beta. Then sum of the roots alpha plus beta equal minus b by a equal minus 3 by a 17 equal 3 by 17, sum of the roots, and product of the root alpha beta equal c by a, here c 14 a 17, 14 by 17, 14 divided 17. New equation, find the equation whose roots are the sum and product of the roots of the equation. This new equation, this equation, sum, roots, alpha plus beta, this sum and this product. Now, sum of the roots, therefore sum of the roots, alpha plus beta plus alpha beta, তাহলে alpha plus beta plus alpha beta, putting the value of alpha plus beta 3 by 17 plus alpha beta 14 by 17. LCM 17, 14 plus 3, 17 by 17, 17 by 17 equal 1. Sum of the roots is 1 and product of the root alpha plus beta into alpha beta. Therefore, product of the roots equal alpha beta into alpha plus beta, putting the value of alpha beta and alpha plus beta, that's mean alpha beta 14 by 17 multiply 3 by 17, 14 by 17 multiply alpha plus beta 3 by 17 equal 42 by 289, 42 by 289. We get the sum of the roots and product of the root and make the equation x square minus sum of the roots into x plus product of the root. We get this condition the required equation is x square minus sum of the roots 1, the x, sum of the roots into x, 1 into x, that means x, and product of the root 42 by 289, then 289 LCM, 289 x square minus 289 x plus 42. This is the required equation of the quadratic equation. Number 4, if the equation ax square plus bx plus c equals 0 and cx square plus bx plus a equals 0 have a common root, therefore the two roots of this equation same common root, have a common root, then show that c plus a equal plus minus b. There here quadratic equation ax square plus bx plus c and cx is equals 0 and cx square plus bx plus a. If alpha be the common root, then equation become a alpha square plus b alpha plus c equals 0 and second equation c alpha square plus b alpha plus a equals 0. A alpha square plus b alpha plus c equals 0 and c alpha square plus b alpha plus a equals 0, and solving the equation by cross multiplication method, then we get alpha square divided alpha equal 1 divided alpha square b ab minus bc, alpha square divided ab minus bc, alpha divided c into c, c square minus a square, 1 divided ab minus bc, then first and second condition, from first and second condition alpha square by ab minus bc equal alpha divided c square minus a square, or alpha square divided ab minus bc, here ab minus bc common b, a minus c equal alpha by c plus a by c plus a by c minus a. Okay, alpha eliminate, then alpha by b equal 1 by a minus c minus a, that's mean minus common minus c plus a, or alpha equal minus b by c plus a. We get the alpha equal minus b by a plus c. This is the first and second condition, and next second and third condition. second and third condition, second and third condition, second and third condition, alpha by c square minus a square, c square minus a square equal 1 by ab minus bc, alpha by c square 1 by ab minus bc, a square minus b square form, or alpha divided c plus a into c minus a equal common 1 by b common a minus c, okay, or alpha divided c plus a c minus a equal 1 by minus b into c minus a, minus b into c minus a, minus b into c minus a. Then c minus a cancel, or alpha equal minus c plus a by b minus c plus a by b. We get alpha equal minus c plus a by b and alpha equal minus b by a plus c. From this is the value of alpha and this is the value of alpha. So minus c plus a by b equal minus b by a plus c. Next condition, we get minus b by a plus c, minus b by a plus c equal minus c plus a by b, minus c plus a by b. Both side minus minus cancel, or b into b equal a plus c into a plus c, a plus c into a plus c. That's mean b square equal a plus c into a plus c whole square, or c plus a whole square equal b square, or c plus a equal plus minus root over b square, plus minus root over b square, or c plus a equal plus minus b. Therefore, c plus a equal plus minus b. This is the condition of this equation. Therefore, c plus a equal plus minus b should. Okay. C plus a equal plus minus b. Number 5, if the equation x square minus px plus q equals 0 and x square minus qx plus p equals 0 have a common root, similar problem, then show that p plus q plus 1 equals 0. So have a common root two equation x square minus px plus q and x square minus qx plus p. Then equation becomes alpha square minus p alpha plus q equals 0 and alpha square minus q alpha plus p equals 0. By the cross multiplication method, alpha square divided minus p square plus q square, minus p square plus q square, alpha divided q minus p, 1 divided alpha divided q minus p, 1 divided minus q plus p, by cross multiplication method alpha square alpha 1. Then alpha square by q plus p into q minus p, or we get alpha square divided q plus p into q minus p equal alpha by q minus p equal 1 by minus q plus p. That's mean common minus p minus q. Now, first and second condition, alpha square divided q plus p into q minus p equal alpha by q minus p. Alpha square or alpha by q plus p equal 1. Multiply both sides by q minus p, alpha by q plus p, or alpha equal q plus p. Alpha equal 1 into q plus p, q plus p. And second and third condition, second and third condition, second and third condition, alpha by second and third condition, alpha by q minus p equal 1 by minus p minus q. 1 by p minus q, or alpha by q minus p equal minus 1 by q minus p, both sides q minus cancel, or alpha equal minus 1. Alpha equal minus, we get alpha equal p plus q and alpha equal minus 1. Then we get p plus q equal minus 1. Then we get both are value of alpha, p plus q equal minus 1, or p plus q equal minus 1, or p plus q plus 1 equal 0. Therefore, p plus q plus 1 equal 0. Next problem, similar problem. If the equation x square minus bx plus c and x square minus 6 plus b differ only by a constant, then prove that b plus c plus 4 equals 0. Similar problem, alpha and beta, first equation of the roots alpha and beta, second gamma and delta, and differ only one constant. That's mean alpha minus beta constant k and gamma minus beta k. Then you solve the problem. Homework B, if the equation x square px plus q equals 0 and x square plus qx plus p equals 0 have a common root, then find the root of the equation 2x square plus p plus q minus 2 into x equal p plus q minus 2 whole square. And second equation, if the roots of the equation x square plus bx plus c equals 0 are alpha beta, from the equation whose roots are alpha plus 2 and beta plus 2. Thanks to all.